Hi, folks. This is Ada. Today I will be explaining the elliptic curve ElGamal encryption algorithm, a widely used public key encryption scheme based on the combination of elliptic curve cryptography and ElGamal encryption algorithm. But before we begin, please like the video and do not forget to subscribe to the channel to stay up to date with latest videos. Also, your comments are more than welcome. Thank you for your all support in advance. Elliptic curves can be represented in various forms, such as Weierstrass, Koblitz, and Edwards forms, each with their own advantages. The elliptic curve ElGamal encryption algorithm provides secure communication over insecure channels and offers efficient encryption and decryption operations. Let's have a look at the key points of the cryptosystem. Key generation. The algorithm involves key generation, where a user generates a private key D and a public key Q. The public key is calculated as Q is equal to D times G, where G is a predefined base point on the elliptic curve. Encryption. The sender will encrypt a point on the curve instead of a plain message. Firstly, the sender decides an integer message and find the corresponding point on the curve as secret is equal to message times base point G. Secondly, the sender generates a random integer R and calculates the random point as C1 is equal to random integer R times base point G. Thereafter, sender calculates C2 as random integer R times receiver's public key Q plus secret. Finally, sender sends C1 and C2 pair to receiver. Decryption is based on the formula C2 minus private key times C1. The receiver firstly calculates private key times C1. Then, finds its negative point. Negative of a point must be on the curve and addition of a point itself and its negative point should be the identity element, denoted as O, which is a special point that serves as the neutral element for the elliptic curve group operation. In Weierstrass curves, negative point of x and y is x and minus y. In Koblitz curves, negative point of x and y is x and minus y. In Edwards curves, negative point of x and y is minus x and y. The receiver finds the negative point according to the adopted curve. Finally, the receiver adds that point to C2. This will restore the secret. Notice that secret is a point on the curve. The receiver restores that point instead of the plain message. Extracting message from that secret requires to solve elliptic curve discrete logarithm problem, which is challenging. In conclusion, the elliptic curve ElGamal encryption algorithm provides a secure and efficient method for encrypting and decrypting messages using elliptic curves. It offers advantages such as smaller key sizes and faster computations compared to regular ElGamal encryption. The security of the algorithm relies on the hardness of the elliptic curve discrete logarithm problem. Despite this, elliptic curve ElGamal is widely used in various applications due to its robustness and efficiency. Thank you all for watching and see you next time.